My name is Israel Ekbo. I'm a cloud solutions architect with Microsoft Global Partner Solutions. I work with ISVs and service partners to help them with whatever they want to build on Microsoft Azure. Confluent is one of my very good partners, so we build a lot of things together, and jointly we help other customers that are doing the same to build on Azure. My focus is on building AI apps and data workloads. So I have my colleagues here, Reshmi from Microsoft and Ankita from Confluent. So they're going to be joining me to present today with you, today. So we're going to talk about a couple of things. There are several challenges that you might encounter when building AI applications. And these are things that, regardless of the industry you are in, you might come across it. Sometimes it might slow people down from being able to accomplish their objective. So we're going to cover some of those challenges. And then towards the middle of the talk, we're going to talk about how Confluent Cloud on Microsoft Azure, particularly the latest version of what we have available, is really helping with building these AI apps to overcome a lot of those challenges. And then we have a quick demo that we would share with you. We'll also have a QR code where you can go and download the code later on this evening after I've taken out a few things. And then we'll open it up for question and answers. So if you have any use cases that you are considering, how and if Confluent Cloud can help you, we are here. You know, the Confluent team is here, the Azure team is here, and we can discuss how to help you with that. So one of the first things we want to talk about is the challenges. So these are some of the general things you're going to encounter when you are building these applications that use AI in so many different ways. We have so many different options. Sometimes you might sit down and say, okay, I want to build this, but what do I use to store my data? What do I use to analyze the data? What do I use to queue up the data? This can become very, very overwhelming. So these are things that myself, Ankita, Reshmi, and some of my other colleagues are facing. We see customers that are overwhelmed with the options. It's kind of like going to a grocery store. You see like 75 different cereals, and you're like, oh my goodness, like which one do I pick? Just to have breakfast. Similarly, here we have the same thing, and how you connect them together depends on the type of data and all those things. And it can become very, very intimidating just to get started. So these are some of the things that slow you down. And we'll show you how Confluent Cloud can help with that. Another thing is now you end up picking the solution, and you don't really have any idea how much it's going to cost. So this can be a challenge. It can slow, it can slow you down. And Confluent Cloud, really does a good job in helping you streamline the number of pieces that you need to accomplish your goal. So in the end, we just end up focusing on just solving the main objective instead of worrying about becoming an expert in all these different tools that we need to mash up together to get the task done. Another thing where we see people have a lot of challenges is bringing data from so many different sources. You may have data coming from blob store, data coming from HTTP triggers, data coming from different queuing systems, data coming from inserts, deletes, updates that are happening at the database layer. All these different things can become very, very challenging if you need to find a way or a mechanism to bring all those data and route it to your database that is going to be powering the AI app. With Confluent Cloud, we don't really have that issue because the tools and the infrastructure and the capabilities that Confluent Cloud provides allows us to handle this data wrangling in a very simple way. It also simplifies the compliance phase and the security aspect of it. So this is another challenge that you're going to overcome. And when it comes to scaling, whether you are dealing with a small set of data or whether you're dealing with terabytes of data, we have seen customers and clients of ours and partners that have dealt with this. So this is not this is not a problem. We just want to, as a partner, help you to focus on your business problem instead of becoming the expert in these in these data products. And then another thing that we see is that you might find out that a particular technology is very good at doing something, but once you deploy it in production, you end up seeing that the amount of studying and the amount of search that you have to do, to read books, to do web searches, to understand different scenarios and different issues in production. Sometimes that can be a very big challenge, and we don't really want you as a customer, or you as an architect or a developer or a business person to focus on these challenges. We have a dedicated team that can help you get started right away with some quick starts and some training to help you get started with that. And then another thing is, when it comes to keeping track of what model you are using, what version of model you are using, behind the scene, we can leverage Confluent Cloud to simplify all these different workloads. So this is something that we are very, very excited, very, very proud to share with you when it comes to solving these problems. The last thing I want to keep track of is keeping track of what is happening in different phases. There may be challenges like maybe you are deploying a particular model. You have maybe 1 million tokens per minute. How do you distribute this limited resource that you have across multiple customers? So you have to be able to keep track in real time what a particular customer is doing, any issues they are having. With Confluent Cloud, the capabilities that we have baked in allows us to simplify how we do this monitoring and how we maintain all these things. So there are certain capabilities that have just been made available on Microsoft Azure, where Confluent is now not just like a marketplace offering, like some of the other products, but it is now baked into the Azure ecosystem, where you can deploy these Confluent resources just like how you would deploy any other Microsoft Azure product or capability. So to discuss this, I'm going to invite Reshmi and Ankita to come and give you more details about it.
Thank you so much, Israel. So once again, we'll do a quick introduction of us, because I guess it's already been very evident, but yeah. I'm Reshmi. I'm the product manager from Microsoft, and I work with Azure Native ISV Services, which you'll quickly see what we're going to talk about.
Hi everyone. So my name is Ankita. I'm product manager in Confluent, and I handle this whole marketplaces as well as this whole partnership that we are going to show you the demo in very short period of time.
Yep. So to pick it from where Israel left, we are talking about a love story which has emerged between Azure and Confluent. And how do we make sure that this story actually blooms and glooms, right? So we're talking about Azure Native ISV offering. So what do we do in Azure Native ISV offering? Confluent Cloud is now provided as a solution in Azure in Marketplace. So if you are a customer who uses Azure services and you would also like to use Confluent as your data streaming solution, which you should very likely definitely consider, you don't have to jump between the platforms now. You can do all at one place while staying at Azure Marketplace and have the two stories together. We also have the integrated layered provisioning between the Confluent Cloud as well as the Azure Marketplace to make sure that all your apps and the Kafka data is being managed at the same place.
Coming to the next slides. So why you need to use the Confluent Cloud in Azure? Confluent is available through the different marketplaces. It's available without the marketplaces also, and even the on-prem also. But why Confluent Cloud on Azure? So when you install the resources for the Confluent in Azure, you'll have all the resources streaming and the Azure streaming in the Confluent Cloud. You can have a single sign-on feature. When I say single sign-on, it's deeply integrated with the Azure AD, and we even call it a single click experience as well. We have support for different Azure services. We can use these resources using Azure Portal, CLI, as well as the PowerShell as well. And yeah, you have a unified billing across all the Azure resources. You just install and use the Confluent resources, and then you don't need to worry about whether you need to add any credit cards or any different payment methods. Everything is being handled directly from the Azure marketplaces itself. To you.
So what can you do today with the partnership that we have with Azure and Confluent? This love story has been going on for a couple years now, and we have already worked on a couple of deeper integrations that you can make use of as of today. For example, we can start off by managing all your RBAC needs in terms of adding user permissions, adding users into your organization, giving them different roles and accesses. Everything can be done from the scratch at Azure itself. So you create your organization and you can already just go give them permissions. The second part, which is definitely something that you would be interested in if you're looking into a migration journey where you already have a Confluent organization and now you're like, hey, I would like to have better advantages, which I am getting as an offer being a native service, right? You can link your existing organization. You don't have to create something from the scratch. You just pick and shift your organization and we can make sure the journey just continues where you left. And we can also connect to the compute services via service connector. So if you're using something like an Azure Blob Storage, Azure Functions, anything of that sort, which basically acts as your front end and you want the data streaming to happen, you now can plug in your Confluent Cloud as a Kafka connector with Service Connector. All of these are generally available as of today, and you get all these perks if you are on Azure Native ISV Services Confluent Cloud offering.
So is that it? No, it's not. There is a more. So you are one of the few folks that we are giving a preview announcement. So now a Confluent connector, which is a bone for Confluent Cloud, it's available right now right away from Azure portal itself. So you can go ahead and create the Confluent connectors. You can create the Confluent resources directly from staying in the Azure portal UI. And what will happen is you sign up to a Confluent Cloud. I'm talking about the whole journey. You sign up to the Confluent Cloud from the marketplaces. What next you will do? You would need to add the required people. Like you need to add your developers who has the permission or who has actually use case to solve it. You can do it right away from the Azure portal. That's she mentioned already that you can have the permission management over there. What next? Now you have a data stored in a Kafka or on any of the connectors. You can use connectors while staying in the Azure portal itself. So you don't need to leave that Azure ecosystem which you trust very well. So we are providing you all the capabilities while you are staying in the Azure portal. And here's a blog post that we have created. Please do scan and see what's more is coming up for it.
Yep. Thank you, Ankita. And to just add on to it, it's a preview function which we have just released, like it's hot off the press. So please do try it out. Please let us know how the experience goes. We are totally open to all the feedbacks. Currently, we support the connectors just for Azure Blob Storage. That was our beta release, but we are looking on to releasing for all the other Azure services on the basis of the asks and needs of the customers. So definitely, please let us know how the experience goes.
Yeah, and we'll be here to hear directly from you folks what extra that you want you.
Yeah. Cool. So moving on, I think we have talked a lot about what are the benefits of using Confluent on Azure. But what are the generic benefits of using Confluent Cloud? And these just pertain to a lot of pain points which Israel had already spoken about, right? So with the solution being available to you, you are basically cutting down a lot of complexity in terms of managing your data. Everything is streamlined. You have a lot of cost savings. I'm not going to go through all the points because we know for a fact that everything that has been spoken about during the problem statement stands true and stands very relevant. And Confluent as a solution, which we've been hearing since morning, already does a great job in terms of making sure each of these benefits is very economically available to us. We put away our stress of managing the data. We only focus on how do we work on the data, the results. We don't worry about the management. So with that, what we're going to do is we're going to invite Israel back to the stage and we're going to look at a live demo with a use case scenario which is very relevant to any of us. Israel.
Thank you very much.
Thank you.
Sorry. So earlier on today in the keynote, there was a discussion about a retail scenario where we had to deal with several complexities that had to do with managing inventory, keeping track of different things within the business. So in this demo, we're going to pick a very simple business, Condoso Retail, that has a grocery department, and we are going to be going through a scenario where the grocery manager wants us to build an AI app where they can just call it Condoso, tell me what is going on with this product. And we're going to see some of those details. So in this particular scenario, it's a very simple use case. So we have this grocery store that has 5 products, just to make it simple for us to see how to use Confluent Cloud to solve this. In this scenario, we have suppliers and vendors that are bringing in inventory. So one of the data streams is inventory replenishment. So different vendors are bringing these grocery items to come and supply to the grocery store. So what is that doing? That is increasing the inventory count, making it go up. we now have another data stream where you have customers are lining up to buy these items. So as the customers are buying the items, the inventory count, is going down. Then you have a third data stream where you have customers that already purchased the product, but now they want to come and return some of these products. So as you can see here, the first two event categories are making the inventory count to go up, and the last event stream is making the inventory count to go down. So if you have all these different things happening at any given time where the vendors are bringing inventory to the warehouse to increase the count, people are coming to buy it to reduce the count, customers are coming back to return it to increase the count again, if it is acceptable. How does the manager have a very quick answer to say, okay, how much of this particular item do I have? Do I have to put in a new order for the supplier to replenish the inventory? Do I have to hold off? Or do I tell the customer that it is sold out, or they have to wait? So in order for us to be able to build this AI application to answer this question in real time, because this is something that that's happening throughout the whole day, and we have to be able to give an answer at any given second. So we have to find a mechanism to keep track of the events that are increasing the inventory count and the events that are reducing the inventory count, and for every particular product, how many of it do I have on hand right now. So to get started with this, we initially started with a much more complicated architecture. The different event categories are happening in Blob Store, so that typically causes us to trigger an Azure function when the inventory replenishment happens, when somebody has made a purchase or when somebody has returned a particular item. Then that will be processed and maybe put in service bus so that we can now trigger another function that would happen and then now put it in Cosmos DB so that now our AI application can now come and receive the query, go to the database, retrieve the information and display it. So as you can see, keeping track of all these different things and keeping track of the math to add, to subtract, to add, to divide and keep track of all these averages can be a very complicated thing to implement. And sometimes you might end up with defects because you're not able to simplify it. So how do we make this simple with Confluent Cloud? Well, Confluent has this Kafka service, and if you're not really familiar with Kafka, Kafka is like a database table where you put put in information like messages, and as you put it, it is forming some kind of queuing system. So when we have all these different data streams, we are able to simplify this by having the Kafka connector monitor the Blob Store, and anytime we receive an inventory replenishment, anytime we receive a purchase, anytime we receive a returning event, we put that inside the Kafka topic, and then immediately we have a different capability called KSQL, which allows you not to manipulate this data using code or Python code or Java code or Scala code, where you can use a simple SQL statement, aggregate all this data, add, do addition with the one that are increasing the count, and then do subtraction with the one that is reducing the count, and then you just put the final result in the Cosmos DB database. So at any given point in time, if we have a replenishment, if we have a purchase, if we have a refund or a return, that is calculated in real time, and the inventory for that particular product ID is updated instantly. And then now, when we now come to use our language model to say, okay, tell me how many of this product do I have left, we can easily query Cosmos DB, retrieve the answer, send it back to the language model, and then it is able to spit out the answer. So that is what we're going to do. And this particular link is going to show you how to do this. So once it is evening time, maybe in a few hours, we will update this link, this GitHub repo, and you can follow along to see how we got to the answer. So how do we do that? Let's start with the Blob Store to see what happens. So let me exit out of here. Now inside my Blob Store, inside the Blob Store, we have the data going into all the different. We have all the data going. Sorry, this is not Blob Store. This is storage account. So in the blob store, we have these different containers. So the containers keep track of the different things that are happening, the product information, the replenishment, the purchases, and the return. So that is where the data is going to be going into. But now we have to find a mechanism of making sure that as soon as this particular data drops in any of these containers, Confluent Cloud can pick it up and put it inside Kafka immediately. So how do we accomplish that? Well, inside the Azure portal, once you are logged in, you can go to your environment, and then inside the environment, you can create what we call a connector. So the very first thing here is a Cosmos DB connector. So this is the one that pulls data out of Kafka and puts it in my Cosmos DB. But before we do that, we need to make sure that we create a connector that can pull data out of Blob Store into my Kafka topics. So to do that, we already created all these 4 connectors that are handling everything in real time. But I just want to show you how to create one, from scratch. So to do that, we come over here. We have 2 categories. So the first one is called source. So this is the one that brings data from wherever you are monitoring or watching inside Kafka. And the second one is called a sink. So the sink is the one that pulls data out of Kafka and puts it in the final data store like Cosmos DB or AI Search that we're going to be querying with the language model. So in this particular demo, what I care about is creating this source connector. So we can call it grocery demo, grocery source demo connector. And it's supposed to be in this environment and in this cluster. And this is the subscription that I want to use. And then I showed you already previously the storage account that we're using to do this. So the storage account is grocery demo, and the containers are these 4 containers. So I can now pick that I want to monitor replenishment. So when I do that, I click on next, and then I pick my data type. My data type is JSON, and then I want it to send it to a particular topic, replenishment. And then I want it to grab any file that has been uploaded in this replenishment folder. So as you can see here, we have several files that were uploaded. So this syntax here says that send all these files to a topic called replenishment. So any file that is uploaded. And then we can take a look and review. So what we have done is we are creating a blob store source connector, and we are putting it in this environment and for this storage account. And anytime something is dropped inside this particular container, we want Confluent Cloud to capture it and put it immediately in the Kafka topic. And then we can go ahead and create. So this takes, I believe, about 2 minutes to happen. So while that is in progress, I'm going to move ahead and show you the ones that we have already done. So in this particular scenario here, we had already uploaded data into these replenishment topics, and the data has flown into Confluent Cloud. And in Confluent Cloud, we have the following topics. So the data went into my replenishment, into my returns, and into my purchases. So the replenishment is increasing my inventory count. The returns is also increasing my inventory count, and the purchases is making the inventory count to go down. So I want to be able to aggregate all this information and then summarize it for each product that I have and put it in Cosmos DB. So we have to aggregate this data from all these 3 different sources. So how do we accomplish that? If you are familiar with KSQL, you can use this to do the addition. So this first part here is keeping track of the part where the inventory count is going up, and the second part is keeping track of where the inventory count is going down because of purchase. And we call that quantity. We have the product ID, and we send all that information to the final table, to the final topic called inventory. Now, once the data arrives in my inventory topic, it is now time for me to pull it out of the inventory topic and put it in Cosmos DB. So as you can see, we had a connector that handles that. From the inventory topic, it is going straight to Cosmos DB. So now in Cosmos DB, we are now able to run our query from the language model code to Cosmos DB to say, okay, for this particular product, how many do I have on hand? So this makes it simple for you to answer the questions without having to go back and forth. When you eventually get access to the code, you're going to see that we have this instruction here, and we also have another instruction that tells the language model exactly what to do. So in here is the name of the function, and the function is going to call a Python function to answer the question. So let me show you the code for that. So when you come inside this, you're going to be able to take a look at it. 1 second. That's not the one I want to show you. So this is the code here. So we have these four functions that we have registered. The first one is able to answer questions about inventory. The other one can give you real-time updates on how many replenishment has happened, how many items have been purchased, and how many items have been returned. And then we have another one. So in here, if you're familiar with how to do function calling, we have to specify what the function is doing and the parameters that the function expects. So once we do all of that, we are now able to register the function app. And in here we have two HTTP endpoints. The first one is the Esther controller. The second one is the Solomon controller, which is the names of the virtual assistant. And then now, when the function apps get started, you should be able to see it listening on this specific port 7070. So now I can come here and start to ask the question. In my examples, I have 5 products. So let's take a look at the sample data. So this first product here is an orange. The second one here is tangerine, and you have the unit price for each of them. But the question we want to find out is, now that we have received this inventory the inventory is being replenished. Some items have been refunded or returned. Some items have been purchased. How much of this particular product, how many of the orange do we have left? So when we ask the question, what ends up happening is that inside the controller, we are going to hit this particular function, this get inventory count function. And when that happens, as you can see here, it is accepting a product ID as the only parameter, and it now goes to Cosmos DB, run a query against that particular Cosmos DB collection, and then get the exact count that has been summarized, and then we can return it back to the language model to answer the question. So when you have time, take a look at this, and you will see exactly what is going on in the code. So to finalize my demo, let me go ahead and execute this so that you can see what is taking place. So in here, I have the endpoint for the code that is running locally. I have this conversation ID. Why do we need to do this? So we need to do this because you have so many different users that could be interacting with this particular language model. So how do we separate that, Ankita is the one asking the question, or Reshmi is the one asking the question, or I'm the one asking the question? Well, we keep track of it by putting some kind of tracker behind the scenes so that we can keep a history of a particular conversation that is going on, and we can be able to reference information as we're doing that. So if we now go ahead and send this request, it will query the database, and then when it comes back, it should have been able to tell us that we had a particular number of products, remaining. So if we change the product to a different one, it should be able to tell us a different inventory count, because different products have different inventory counts. So this one here, for the first one we had 35 remaining. For the second one we had 28 remaining. So this here just shows you how simple it is for you to implement this. If we had to do this with a different set of products, it would have been much more complicated for us to do the math, for us to do the keeping track, and for us to manage all the different products or resources that are needed to make this happen. So I hope this was useful. If you have any questions, we are going to be hanging around and to take any questions that that you have. Again, this is the link to the demo. We're going to have all the code samples uploaded this evening, and you can download it and follow the instructions to run it and see and see how it goes. Thank you very much for your time. We're going to take any questions you may have now.